Thank you very much. My name is Andreas Møller, and I am a CTO and co-founder at Sentia, which is a small company here in Copenhagen. And the talk I'm going to give is about functional programming in JavaScript. And I gave this the first time in November last year as part of a 3-part talk, functional programming. And I basically just cut that down to 20 minutes. So it's going to be really fast. I'm just going to throw code at you. But I'm sure because it's Copenhagen, we're gonna handle it. We're gonna manage it. It's not like London standards. The reason why I want to talk about functional programming is because, first of all, it's very hip right now, and there's a lot of value to looking into this paradigm, especially in JavaScript, because JavaScript kind of lets you do anything you want. So it's quite a good language to sort of start and playing around with, well, what should I do now that I can code in any possible way I would like? What are actually good ideas? What are good paradigms to adopt? And we get to play around with things that you don't in other languages. And this is a quote I really love from John Carmack. And if you don't know who he is, he's the guy who made Commander Keen. He also has some like less success like Doom and Quake, but he made Commander Keen. So this is a man we need to listen to. When we talk about what functional programming is, it really is kind of initially as simple as we think it is. It's about programming with functions. But it's like really just programming with functions, and functions for everything. Any problem you have, functions. Functions is already the answer. In this case, we have a simple add function to start with, take 2 arguments and returns the sum of them. Very simple function. I'm pretty sure everyone's with me here. And when we look at this and the way we want to talk about in functional programming, we want to start sort of putting some terminology in use. In this case, we say we have the function add, and we apply the function to x and y to get the sum of x and y. We also kind of want to talk about the data the functions use. So in functional programming, we have functions and we have data, and they don't mix. So in object-oriented, we have objects that have data, they have methods. We have a big sort of composition, well, not composition, but we have a bit mishmash of these things. And in functional, it's very data and functions are separate. We apply functions to data to get other types of data. In this case, I stole a type signature from Haskell just to make things harder. And what we do here is we say we take a number and another number, and we get a number back. That's basically what that means. And in this case, 3 is just a number. So it's just a simple way of saying, of thinking about the types of data we put in. And later on, we'll see why we kind of want to be very specific when we're thinking about types. We want to use functions as our small reusable components. We want to apply functions, we want to reuse functions, we want to build everything with functions. And because of that, we, of course, can create simple functions like this one, which what it does is it merges 2 objects together, taking all the properties from both of them and returns a third one that has all the combined properties. And what I did here is basically the string :A is just a way of saying the key is always a string. A is, well, something. We'll call it A for now. And we get 2 of those, we return a third one that looks just the same. It'll just have more properties. One thing to note here is that when I did the object assign, I passed in an empty object, and that's because I don't ever want to mutate my data. I want to leave the original input completely untouched, so if someone else needs to use it, I haven't screwed it up. Like, I'm not going to mess up your data, I'm just going to borrow it and then do something else with it, and it's still the stuff you thought it was. Another one, just to make things, we're going to build up a whole library of stuff we need to use, so we're going to build stuff up. You don't need to focus too much on the implementation of these. Some of them can be a little bit sort of complicated sometimes. Initially, it gets much easier as we go along because we start reusing the same functions over and over and over again. So in this case, all we're doing from pairs takes a list of string of key value pairs. So if you look at the type signature, we say it's an array, and inside that is an array with 2 elements. The first one is a string, and the second is, well, something. We don't care at the moment. And what we get back is an object with strings as keys, something as values. This function doesn't know what the something is, so we just call it A. In this case, we can do it by reducing in and then merging all the objects together. But basically, we go from a list of key value pairs to an object. And again, all the input stays completely untouched. Now, because we want to reuse these functions a lot, we want good ways of reusing functions. And one of the things we want to do, we want to think of them as Lego bricks that sort of snap together to make more complicated Lego bricks. We put functions together, we compose them as we call it, to make more complicated functions. And in this case, what this does is you give it a function g and a function f, and it returns a new function. If you look at x, arrow, whatever the result is a function. And what all it does is it calls f with the argument x first, and then g after that. So the result of f goes into g. This is pretty simple. Basically, we're calling the functions from right to left, passing in the value in. Whatever comes out of the function goes into the next one. We can make this a little bit more complicated because we like making things a little bit more complicated initially to then make things simpler later on. In this case, all we're doing is exactly the same as before, but we basically just made a function that doesn't care how many functions you give it. It still has this. We pass one argument in from the right. It keeps sort of passing the value through the function all the way out to the left. Now, why do we want to do that? And why do I have my duck up? We want to do this because now we can start making quite simple functions, complicated functions quite simply. The first one we'll do here, say the first function on the right, and remember we do this from right to left. The right function says, take a something x, it's a string in this case, but we like using not too specific terminology because this function still doesn't know what the data is. We can use it in all sorts of ways, so we don't want to call it something too specific. It's sort of counterintuitive for many paradigms, but in this case it actually makes a lot of sense. So we split the string by a question mark, and then we pass the result of that, which should be an array with 2 elements, or possibly more, but since it's a URL, and I said URL query, it's got to have 2. We get the last one of it. So this basically just takes a URL and gets everything after the question mark. We can make more complicated things. We can make one, let's say we have one called split pairs, which kind of does the same thing, but for equals, except it does it for every element in a list. So that's why we do the map. And now we can start composing functions together in an interesting way. We can say, well, let's start by splitting by the ampersand, which is splitting a query by every pair. Then we map over the list of all these pairs, which are strings, and we actually split the pairs. So we now have a list of key value pairs. And of course, we already created a function that can handle those, and it'll turn it into a map, or to an object, as we call it in JavaScript. So this one takes a query from a URL and gives you a object of all the key value pairs in that query string. And I don't know if you ever implemented this. I think a lot of people have, and they're never particularly simple. They always have a lot of moving parts, and they're always often somewhat annoying to deal with, even for something that should be a quite simple function. Now, another tool in our toolbox is called currying. And this is a fun function. If you want to read it, you're perfectly welcome to, but it's not the simplest way of understanding what currying is. It's a little bit of trickery magic that JavaScript lets you do, but what we want to get at is what currying means and how we apply it. So we're going to take a function and we're going to call it split. What it does is it takes a string and splits it by a separator. And what we did here is we called curry on that function. We passed it into the curry function. And what it does is return a function that you can choose to apply one argument at a time. So if I give split only the ampersand, but not the actual string to work on, it's going to give me a new function that will split it by the ampersand. It's basically said, I already got the first argument. Now the new function is waiting for a second argument. And when I call it with the second argument, it actually applies the original functions. So this really gets a lot of people confused. And why would you do this? This is just adding a lot of complexity to simple code. But it allows us to do some really, really fancy stuff. Not just fancy, actually really useful. So we're going to start by taking all our favorite functions, and then we're going to call curry on the whole thing, because we like currying now. Just trust me on this one so far. And now we can do interesting things. Now we can actually say, well, now because we can partially apply our functions, one argument at a time, split, for example, the first one on the right, we remember we gave it the ampersand and then the string. If we only give it the ampersand, it waits for a string. When we give it the string, that means when we call the whole thing, it'll split by the ampersand, just like our last parse query did. Now the next one is map, split. That one looks a bit more complicated, but again, we remember split by equals is a function, the first one we call it like that, gives us a function that will split a string by the equal sign. And then map is essentially a way of saying take that function that works on one element and make it works on list instead. So because the first function on the map is what are we going to do with each element, the second argument, which is waiting for, is the list of things. So now actually our parse query function looks a lot simpler because we can just put these functions in like that. And if you notice, one interesting thing about this is there's none of these functions except parse query has anything to do with URLs, has anything to do with the domain we're in. These are really generic functions. Map applies to all lists with all kinds of functions. Split applies to all sorts of strings. There's nothing URL domain specific about it. These are just tools. These are just really generic utilities. So in one line, we've now created a parse query function. And very few of those are really one line. That's, or at least when they are, it's not a good thing. Now that we have our fancy toolbox and we can start playing around with these things, this whole mapping thing, this whole taking a function and making it work on list instead of single objects, that's really useful because then we can write all our functions to be things that work on single elements. And hocus pocus, we now have a version of them that works on lists. Like, that's really cool. We write the function one, we can use it everywhere. Wouldn't it be awesome if we can do that more? So let's make this one. It does exactly the same as normal map, except it works on objects. So it'll create a new object, looks exactly like the same thing, but every single value in the object has been passed through this function. So now we can fix the glaring bug that everyone here saw that wasn't this. Of course, well, you didn't decode your URI component, and I knew you were about to say it, that's fine. No, I forget this every single time I do this. Like, it's just like, oh yeah, eventually somewhere down the line, someone go, yeah, I actually encoded the URL as you're supposed to, but you didn't decode it, and now we have a bug. But in this case, we can actually really, really simple do that for each value, simply by going in, well, now that we got the object, now that we got the key value pairs, we can just map that over decode URI component, and our parse query function is actually complete. It's still one line, it's a little bit of a longer line, but it's less than the 80 character standard. Oh God. I got like way too many colleagues' calendars, and none of them are here. We can also basically take all of this and inverse it and saying, well, if we start by mapping the object into encode URI component, we did exactly the opposite of what we did before, because that's the inverse. The inverse of from pairs is two pairs. Obviously, we get an object, and then we return a list of the key value pairs. Now, then we can join by, it does the same thing as normal string join, works the same way. We go through each pair, we join them. Then we get like a list of strings that are the key equal the value. And then finally, we just join the whole thing by ampersand, and we have a query for our URL. And again, none of these are specific functions. These are all just composing basically utility function. It's a library called Ramda, very brilliant library, definitely recommend it. Does all this for you. Very, very simple to use. Now, one final thing I want to point out is that we can do this with arrays, we can do it with objects. We can also do it with async functions, like promises in JavaScript kind of fit our value goes in, value comes out principle. So in this case, this is just like a basic get JSON. We fetch some stuff and get the JSON out. We can do a little bit more complicated stuff by saying, let's get the JSON of this specific user with the ID, then get out prop. In this case, it's just a simple accessor, basic get thing on that key, like get whatever is on the permission of, in this case, a user that's returned from the server. And this kind of thing, like first of all, the then part of promises work perfectly with functional program. We pass in functions, we create functions, we can do this really easily. But also, if we apply a little bit of magic and just make our map promise function, which is just calling then on a promise, there's nothing magic here, we can put it into our composition. We can start saying, great, now we're going to concat. Basically, we concat two strings together. We add the ID after URL. Then we can call our get JSON, and now we have a promise coming back, but we don't want to make functions for promises. We just want to make functions for normal data. So what we're going to do is we're going to make our function for normal data, and we're going to call it with map p, and then it will apply to promises. And in this case, we get the prop permissions out, so we already have that again. This was such a basic function, we didn't have to write anything custom for it. Just to make things a little bit more fun, we can start applying all the things we've done all the way through to and put them together. We can do our get users, which is builds a query from a user URL, gets it into the API users, and I did not add get JSON to that, so that's going to be a real problem. There's supposed to be a get JSON at the end, otherwise none of this makes sense. I apologize. And then we can pose that, and then actually map that in. We can filter the one that has the prop admin to be true, which will then get us a list of only the admin users. So we, in this case, if we actually call it, we'll call it with something like that. We'll say get the users, and then we'll give it an object like who are 32 and live in the city Copenhagen. And then it'll get all the users. It'll then filter by the ones that have admin true and return only that list back. And I get almost all of these functions. Almost all of these functions are one line. They're very sort of compact and easy to read. Some of them can be a little bit intimidating when you start, but as you start getting into, well, when I map it over a promise, I'm just taking a perfectly normal function, operating a single value, and now it works on promises. So the reusability is very, very high, and we have to write very little code to solve our problems. And most of the functions we used are library functions. If you have a standard library that supports functional programming, including currying and composition, these two things I talked about, actually quite a lot of our code is just standard things. We just do normal transformations all the time. We just need to apply them in the right context. So we are hiring. If you think this sounds really interesting, if this is something you would like to work with and you happen to be looking, definitely come talk to me. If you're looking for mentorship or something and want to get into programming, definitely come talk to us. If this is something you find interesting.